So my name's Alexander Casper, and I'm presenting my presentation. Thank you for viewing with the DSR. So my presentation is facial contact recognition. So what does that even mean, facial contact recognition? So mostly trying to determine whether somebody can, whether an image that has been viewed by the computer and the model can determine whether somebody was touched their face with their hands or something like this. So trying to get into a little overview as to what made me interested in this topic is that mostly I was interested in trying to determine the motions that people were feeling when, if you could take images of their body language. So from this, it came out like trying to determine various gestures, and a lot of these gestures had to do with touching your hands or touching your face with your hands. So this led me down a certain rabbit hole where I just started to try and determine this gesture initially and use it in application with what's going on with the pandemic. So I used various machine learning techniques to teach a neural network to recognize such these patterns. So the data collection process was long and arduous. I made a data set from scratch and got 12 friends together and convinced them to let me videotape them while they moved their hands around their face, as well as poked and touched their face, and then separated them into a data set of about 7,000 images of touch and non-touch. So from here, I created a pandas data frame, and basically a video is like a long collection of individual frames. Many frames that I had to dig through and find individual images and separate them into what I determined was a touch or not a touch. And some of these images might be something even like putting your hand in front of your face, which is not really clear. Like, is it touching here or is it here is obviously touching. So created a data frame where I cropped and resized all of these, labeled them into their respective directories. So the first model that I went through was I wanted to make it from scratch. So I used image classification using TensorFlow Keras. And kind of like Juan had described, this is a convolutional neural network. And I used a 2D CNN and compiled it with a binary cross entropy and atom optimizer. So since I have two classes that I labeled a 0 or 1, and a 0 is non-touch and a 1 is a touch. Now, then I discovered that I guess 7,000 images is actually a really puny data set, and it wasn't really coming up with such great results. Like at best, I managed to make it maybe 1% better than guessing at random. So I did a bunch of image augmentation to try and use most out of the data that I have. And image augmentation is basically just tweaking around my images so they're slightly different. So whether you flip them upside down, put them 90 degrees, make them bigger or smaller. This helped a bit, but realizing that I'm only one person trying to collect people to take videos of during COVID, I turned to transfer learning. So transfer learning is essentially trying to take the layers that have been passed on from previous learning models. So in this case, I used ImageNet, where I think it's maybe like 14 million images. And with this, like 7,000 images, I can't possibly create the most basic concepts of what even would be recognized as, I don't know, even just texture. So, I mean, as you can see here, it's teaching it like the basics of like what edges are, like base lines, textures, and it can eventually, over millions of images, start to discern things like patterns and objects. And From this, you can, take images of like cell phones and actually use that to determine what could be viewed as buildings. So this is definitely very helpful in my situation. So I ran a few of these through there and started getting much better results. Running my 7,000 images through here, I started off with a ResNet 50 and ended with a validation accuracy of about 51%. So we're looking like 1 or 2% better than guessing at random. But when I ran it through the ResNet 152, validation accuracy all the way up to 79%, and validation loss of around 43%. So I think it did much better given that my situation was actually looking pretty dire and I had spent about 80% of my time just trying to collect data. So I would say that if I were to do this again, if I were to try and get my own data again, I would maybe try and get, it would take even longer, but enough video images would be really cool to maybe try and do a 3D convolutional neural network, as well as a wider distribution of people. I I don't know. I think with the being able to determine certain types of people based on, I don't know, phenotypical differences, maybe more of a 50-50 split between gender. Maybe sometimes people show up with different clothes when they're being videoed the second time, maybe different lighting conditions, angles of their face, things like this. So definitely having obviously more data and a wider diversity of data. But also I ran into so many of these issues that I didn't really have time to do much of an evaluation, and I really wish that I had more to show in terms of confusion matrix or a rock curve or an F1 score. But that's basically my presentation. So if you have any questions after this, here's my email, and this is my GitHub.